transformation. Today I am going to discuss the convolution theorem of the jet transformation, and then we will solve the questions related to the difference equations. Convolution theorem. Let jet transformation of the sequence u1 is uz, jet transformation of the sequence bn is vz. Then if the convolution product of un into bn is equal to, suppose that this convolution product is equal to summation m equal to 0 to n um bn minus m, that means it is equal to, if you put m equal to 0, then this will be your u naught bn. If m is 1, then this will be your un bn minus 1, u2 bn minus 2, then un b naught. So if this is your convolution product, then the jet transformation of un into bn is equal to uz into vz, or you can say that your jet inverse of uz into vz is equal to un star into bn. That means it is equal to u naught bn plus u1 bn minus 1 plus u2 bn minus 2 plus dot 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 un b naught. So the convolution, so the jet inverse of uz into vz equal to this value. So proof. So let us start with the uz into vz. So uz into vz, and we will prove that it is equal to the jet transformation of u1 into bn. So uz means the jet transformation of un, which is equal to u naught plus u1 jet inverse plus u2 jet minus 2 plus u3 jet minus 3 plus un jet minus n plus and so on into vz. Vz means the jet transformation of bn, that will be your summation n equal to 0 to infinity bn jet to power minus n. And if you open just the summation, then this will be your this one. Then bn jet power minus n and so on. Now let us multiply these two sequence. So the first term will be u naught v naught. Then let us take the terms of jet inverse. So from here we will have u naught v1, and from here we will get u1 v naught. Then the terms of z2 inverse will be, now z2 inverse will be u naught into v2. Then the second term will be u2 plus v naught plus this u1 v1 z minus 2 and so on. So this is your product. Now this can be written as, this product can be written as, so this is equal to jet transformation of, we can write it as the jet transformation of u naught vn plus, or you can say, okay, we can write it as jet transformation of u naught bn plus u1 bn minus 1 plus u2 bn minus 2 plus dot dot, then the last one is un v naught. This can be written like this, because why I am saying this is equal to this one? Because if you open its jet transformation, then now the jet transformation of this one will be, say jet transformation of this bracket u naught bn plus un bn minus 1 and so on. Now this will be your equal to n equal to 0 to infinity, then this function into z power minus n. Now if you put n equal to 0, then this term cannot be possible because our negative coefficients are 0. So if we put n equal to 0, then we will get u naught b naught and then z power 0, that is your 1. So now if you open this, okay, I am writing it here. Now this will be your Z, and this U0 Bn is your U1 star Bn. So the Z transformation of U1 star Bn is equal to Uz Bz, and that is what we have to prove. So now in the bracket, let us see why this is equal to this thing. Now the Z transformation of U0 Bn plus U1 Bn minus 1 plus U1 B0 will be equal to, now the Z transformation of this will be summation n equal to 0 to infinity, then this term plus Un V0, then Z to power minus n. Now if we put our n equal to 0, then you can see that this is your negative coefficient, and from here onwards we will have the negative coefficients. So we will just get U0 and V0. Now if your n is 1, then from here we will get U0 V1, from here we will have U1 V0, and rest coefficient will be 0, Z minus 1 and so on. And this is what? This term. So this term can be written as Z transformation of U0 Bn plus U1 Bn minus 1 plus U2 Bn minus 2 plus U1 B0, and that is what we have to prove. So the Z transformation of U1 Bn, therefore the Z transformation of U1 star into Bn is equal to simply Uz Bz, or you can say that the Z inverse of two functions of Z is equal to U1 star Bn. That means it is equal to summation m equal to 0 to n, then Um into Bn minus m. So this is your answer. For example, the Z inverse of, say, Z square upon Z minus A, Z minus B. Now this can be written as Z inverse of Z upon Z minus A into Z upon Z minus B. The first term can be written as, say, Un, and the second term is Vn, like this. Sorry, Uz into Vz, where Uz means Z upon Z minus A and Vz means Z upon Z minus B, and the inverse of this Uz is Un, and which is your, the Z inverse of Z upon Z minus A is 8 for n, and this will be your, similarly the inverse of Z upon Z minus B is B for n. So now the Z transformation of Uz into Vz is equal to U1 into U1 star into Bn, and this is equal to summation m equal to 0 to n Um into Bn minus m. So from here we will have m equal to 0 to n. Now Um means a power m, Bn minus m means b power n minus m. So from here our Bn will be common. So from here we will get m equal to 0 to n, then a upon b power m. So this is equal to b power n. Then if m is 0, we will have a plus a upon b, then a upon b whole square, then a upon b power n. If you take a upon b common, then in the bracket we will have 1 plus a upon b plus a upon b. This is your a upon b. Power n minus 1. So this is your first term is 1, because we are putting m equal to 0, so this will be 1 plus a upon b, and like this. Now you can see that this is your GP of how many terms are there? From 1 to n terms are here, and one term is this one. So this is the sum of the finite n plus 1 terms of GP, and the sum of GP is r to power n, say a upon b power n minus 1 upon r minus 1, assuming that your a upon b is less than 1. So that means now this b power n is common, so this will be cancelled with this one, and so we will have a power n minus b power n is here. This b power n will get cancelled with this one. So this is equal to a power n minus b power n upon a minus b, and this, here we have this b, and this b, I think it has to be cancelled. So they demonstrate we have total n plus 1 terms, so this will be n plus 1, not n. So now, so this is equal to, now we have a power n plus 1 minus b power n plus 1 divided by b power n plus 1 divided by a minus b upon b. So now this will get cancelled, so our answer will be a power n plus 1 minus b power n plus 1 divided by a minus b. So this is your answer. Now let us solve questions related to the difference equation. So the first question is solve un plus 2 plus 4 un plus 1 plus 3 un equal to 3 power n, where my u0 is 0 and un is 1. So let us solve this question. Let us solve this problem. Taking the transformation, we get z un plus 2 plus 4 z un plus 1 plus 3 z un equal to z 3 power n. Now we know that the formula for z un plus 2 is equal to z square un plus 2 minus, I think this is z square un plus 2, then minus z, then I think we have minus u0 minus un z inverse. So this was the formula for z transformation of un plus 2. Then similarly the z transformation of un plus 1 is z un plus 1 minus u0, and the z transformation of u1, say this is your uz, and we know that the z transformation of h power n is z upon z minus a, so this will be z upon z minus 3. Now our u0 is 0, so this term will get cancelled. So from here, this is your z transformation of un, not un plus 1. This will be z transformation of un minus u0, and again from here we will have the z transformation of un minus u0. So from here, if you denote this z1 by uz, then we will have uz minus u0 is 0, u1 is 1, so this will be your z inverse, and again z transformation of u1, say this is your small z and that is your capital Z, and the z transformation of now the z transformation of un is uz and u0 is 0, and we have uz equal to z upon z minus 3. So from here, if you take your uz common, then we will have z square plus 4z plus 3 as common, and in the right hand side this will be your minus z, and in the right hand side we will have plus z. Therefore, now this is your, now in the right hand side, now this is your z plus 1 into z plus 3, and in the right hand side we have z square minus 3z plus 2, that means z square minus 3z plus z, that means minus 2z upon z minus 3. So our uz will be z square minus 2z divided by z plus 1 into z plus 3 into z minus 3. So this is your uz. So z square minus 2z divided by z plus 1, z plus 3, z minus 3. Okay. Now let us compute its inverse z transformation. Now for the inverse z transformation, again we will use the convolution. We will use the residue theorem. And the residue theorem says that the z inverse of this one is equal to the sum of residues of, if this is your uz, suppose that this is your uz, then the z transformation of this z inverse uz is the residue of uz into z power n minus 1 at poles. So now the sum of the residue. Let us compute residue one by one. So residue at z equal to minus 1. So this will be your residue of uz at z equal to minus 1 is equal to z plus 1 into u0 into z power n minus 1 and the value at z equal to minus 1. So now this factor will get cancelled. So we have z square. Now if you put the value of uz here, then this will be your, now this z plus 1 will get cancelled. Then in the numerator we will have z square minus 2z. If you multiply by this term, then this will be z power n plus 1 minus 2 z power n divided by z plus 3 into z minus 3. So now we have to get the value at z equal to minus 1. So at z equal to minus 1, this is equal to, now this will be just minus 1 and minus 1 power something is minus, now this is your minus 1 power n plus 1. So this will be your minus 1 and then here we will have, here we can write it as minus 1 power n plus 1 then 2 z equal to minus 1 power n divided by z is minus 1, so this will be 2 and this will be your minus 3. So this is your 2 minus 4. So now here you can see that this is your minus 1 power n into minus 1. So this will be your minus 3 into minus 1 power n divided by minus 8. So this will be your 3 upon 8 minus 1 power n. So this is your u1. That means the residue at uz for z equal to minus 1. Again the residue of uz at z equal to say 3. So this will be your z minus 3. Then again in the numerator we will have this term uz into z power n minus 1 and the value at z equal to 3. So now this factor z plus 3 will get cancelled and again in the numerator we will have z power n plus 1 minus 2z power n and in the denominator we will have z plus 1 and z minus 3. So z plus 3 and the value at z equal to 3. So this is equal to, now this will be your 3 power n plus 1 minus 2 into 3 power n. Now 3 plus 1 is 4 and 3 plus 3 is 6 and this will be your 3 times 3 power n. So again this is your 3 times 3 power n and this is your 2 times 3 power n. So after subtracting this will be your 3 power n upon 24. So this is your residue at z equal to 3. Then residue of uz at z equal to minus 3 will be z plus 3 z minus z plus 3 into uz of z power n minus 1 and the value at z equal to minus 3. So this will be z power n plus 1 minus 2 z power n divided by z plus 1 and then z plus z minus 3 and the value at z equal to minus 3. So this will be minus 3 power n plus 1 minus 2 into minus 3 power n divided by, now this will be minus 3 plus 1, that means minus 2 and minus 6. So this will be plus 12. Now from here we can see that this is your minus 3 power n into minus 3 power n into minus 3. So this will be your minus 5 upon 12 into minus 3 power n. So these are the residues at different poles. Therefore your solution is, therefore your un will be the z inverse of z square minus 2z divided by z plus 1 into z plus 3 into z minus 3, and this is equal to, the first residue was 3.8 power minus 1 power n, the second was 3 power n upon 24, and the third one is minus 5 upon 12 minus 3 power n. So this is your answer. So this is the answer for the first part. Yes. Now let us solve one more question. So solve un plus 2 minus 2 un plus 1 plus un equal to 3n plus 5. Please note that here we have not given any boundary conditions. So we will solve in the terms of u0 and un. So let us take the z transformation of un plus 2. Solution. Let us take the z transformation of this equation. Okay. Now the z transformation of un plus 2 was z into uz minus, this was your z square into uz minus u0 minus un z inverse, and this will be your 2 times uz minus z u0. This will be your z times uz minus u0, and here this is your uz, and we know that the z transformation of n is z upon z minus 1 square. So this is your z upon z minus 1 square, and the z transformation of 1 is z upon z minus 1. So this will be z upon z minus 1. So in the left hand side we will have uz. Let us take the uz common. So in the bracket we will have 2z square minus 2z. From here we will have plus 1. And now let us take these terms in the right hand side. So this will be z square u0. And so in the right hand side we will get z u0. Then this is your z square, and from here we will have plus 2z. So this will be your z square plus 2z. And this is your unz. So in the right hand side we will have unz, and if you take LCM here, then we will have 3z plus 5z into z minus 1. So this will be your 5z square minus 5z. So that means 5z square minus 2z. So from here we will have 5z square minus 2z upon z minus 1 whole square. Okay. Now let us divide by this term. So our uz will be u0 z square plus 2z divided by z minus 1 whole square. Then the second term is u1 z upon z minus 1 whole square. Then the third term is 5z square minus 2z upon z minus 1 power 4. Now let us take the inverse of this function. So the inverse z transformation will be u0, the inverse of z square plus 2z upon z minus 1 whole square. And here we know that the inverse of z upon z minus 1 whole square is n. So we have the direct answer for this one. And here we will have 5z square minus 2z upon z minus 1 power 4. Z inverse of z square plus 2z upon z minus 1 square is equal to, I think this will be our minus, because now this is your minus minus plus. So if you take it on the right hand side, then this will be a minus. So this is your z square minus 2z, and here it will be your z square minus 2z. So this is your z square minus 2z. Now the inverse z transformation of this term is equal to, this will be your residue of, we can also write it as z inverse of uz. where my uz is this term. Now the z inverse of uz is residue of uz into z power n minus 1 at z equal to 1. And here your z equal to 1 is a pole of order 2. As it is a pole of order 2, so we have dy dz of uz. Now uz is, as it is a pole of order 2, so we will multiply it by z minus 1 whole square into uz. uz is z square minus 2z upon z minus 1 whole square into z power n minus 1, and the value at z equal to 1. So this is equal to dy dz. Now if you multiply this term by this term, then this will be z power n plus 1 minus 2 z power n divided n. Okay, and its value at z equal to 1. So after differentiation, we will get n plus 1 into z power n. So on putting z equal to 1, we will get n plus 1, and here we will get 2n. So at z equal to 1, this will be your, now this will be your minus n and 1 minus n. So that means this is your 1 minus n. So the first term is 1 minus, the residue of this term is 1 minus n. Now let us compute the z inverse of this one. Now the z inverse of this one is equal to, we have a formula for z transformation of n, and the z transformation of n is equal to z upon z minus 1 whole square. So its inverse will be just n, because the z transformation of n is equal to z upon z minus 1 whole square. If you don't know the formula, then you can also evaluate with the help of this residue method. Let us evaluate with the help of the residue method. Now this will be your, as again, this is your pole of order 2, so this will be your, we can write it as z inverse of uz, and this will be your equal to z inverse of, and this will be your residue of uz into z power n minus 1, and the value at z equal to 1, and this will be equal to, as z minus 1 is a pole of order 2, so this will be your dy dz into z minus 1 whole square into uz. uz is z upon z minus 1 whole square into z power this one, and the value at z equal to 1. So now this power is z power n. Now after differentiation with respect to x, with respect to z, we will get n into z power n minus 1. This is your power z power n. So differentiation of z power n will be n into z power n minus 1, and the value at z equal to 1 will be your simply n. So this is your the z inverse of this one. Now let us compute the z inverse of third term. 5z square minus 2z upon z minus 1 power 4. Here you can see that it is a pole of order 4. So this will be equal to d by dz. I am writing directly. So this will be z minus 1 power 4 into this function 5z square minus 2z into z power n minus 1 upon z minus 1 power 4 into the value at z equal to 1. Now as it is a pole of order 4, so here we will have 1 upon 4 minus 1 factorial by the definition of the residue. So this will be your third derivative, and here we will have the factorial 3. Now this is your cancel. So this will be 1 by 6 into d cube of dz cube. Then in the bracket we will have 5z power n plus 1 minus 2 z power n, and the value at z equal to 1. Now let us differentiate this term 3 times with respect to z, and then put z equal to 1. So on differentiating this term 3 times, so on differentiating this term 3 times with respect to z, we will get 5n plus 1 after one time. After second time we will have n, because the differentiation of z power n plus 1 will be n plus 1 into z power n. Then again differentiating we will get n outside, and the power will be z power n minus 1, and then after third differentiation we will have n minus 1, and the power will be z power n minus 2. As we have to put z equal to 1, so that will be your 1, and similarly Here we will have n into n minus 1 into n minus 2. So this will be the third derivative after putting z equal to 1. So now here you can see that our n into n minus 1 is common. So in the bracket we will have 5 n plus 5. Now here n minus 1 is common. So we will have minus 2n plus 4. So this is equal to, now n into n minus 1 by 6 into, this is your 5n minus 2n, that means 3n plus 9. So we can write it as 1 by 2 into n minus 1 upon into n plus 3 divided by 2. So this is your inverse Z transform from this third term. Thus finally we have the solution of the difference equation. Therefore our u1 equal to, this was our 1 minus n, this was our n, and the third term is, this was our 1 by 2 into n minus 1 into n plus 3. Therefore this is your